And for our final speaker tonight, Blaise Porter. Blaise is an experienced leader with expertise in sustainability and social responsibility strategy, including consulting, emissions reduction, and product stewardship and the circular economy. At Sims, she oversees the company's long-term sustainability ambitions and goals to fulfill the Sims' purpose, to create a world without waste, to preserve our planet. She also directs Sims' corporate social responsibility framework and is a passionate advocate for diversity and inclusion. Please welcome Blaise.
Thank you. Thank you very much. Thank you so much for having me here. Again, I feel like I'm echoing everybody, but great to see us in 3D. Great to be here on Gadigal country, and also particularly acknowledging their elders, and that it is Reconciliation Week, of course, and that's a great opportunity for us to reflect on our long history in this morning and the opportunities I think that the built environment has and sustainability practitioners have to achieve and work towards reconciliation in this country. So I'm from Sims, and I think many people kind of heard of Sims. Oh, Sims Metals, I know about you guys. But what you may know is that we've been around for over a century, and actually founded about 5 kilometres down the road in Wilford Street in Newtown. That was the first ever Sims yard. This is what they kind of used to look like. And actually our first ever transport was very low carbon bicycle. And Albert Sims used to go around on his bicycle and collect the metal. So we've moved on from that, but now we're looking back to some more low emission solutions. If we could do it all on bicycle, I'd be a happier woman. But that is us. And of course, so now we are, you know, a global business and the world's leading metal business, and also specializing in data center circularity. So just under 4,000 of us worldwide. And last year we recycled or handled more than 8.6 million tons of metal, predominantly steel, but also of course aluminium, copper, you know, nickel, lead, and, you know, other sorts of metals that you can think of. So at Sims, you know, sustainability is really important to us, and we really feel like that is what we do, right? We're a sustainability business, pure play in the circular economy. And so these are the pillars that we organize ourselves around. And you can see there are commitments to the SDGs as well, and really kind of focusing on, you know, how it is that we create change with our partners, how it is that we close the loop, you know, both for society, for customers, you know, like Capital, their customers like Lendlease, and how it is, of course, that we communicate that and we, you know, uphold the higher standards of transparency and accountability for ourselves in our work. I'll talk a little bit about ourselves. So we've recently brought all of our targets forward, which is super exciting. So we don't want to wait to hang on with things. So this is really about looking at how it is that we can decarbonize our own operations and make sure the product that we handle comes with a low footprint. So we're looking really there at 2030, and scope 3 is one of the topics of the night, of course. And we're just going through the process now of understanding what our scope 3 inventory is for the very first time. I can say that like many companies, it's many times larger than our direct operational footprint. And we are really, you know, seeing the impact of the processing of secondary metal making up the bulk of that inventory. So, you know, really, again, looking at how does the product we sell also contribute to that? And, you know, that's one of the real challenges about aluminium. So this is our place in the value chain. So Sims, what we do is we'll collect all the scrap, and we'll talk a little bit about this, and we process that. So if you have a facade coming out of a building, that might have bits of the building still attached, depending on how good your C&D still is. So that might still be attached to bits of cement, glass, you know, rebar. It might have its own kind of contaminations, like it might have steel screws in that aluminium. You know, there might be all sorts of things. So we will buy that. So we'll buy that from you, and we will process that to try and remove those impurities as best that we can. And then we sell it on to a remelter. So Sims doesn't produce new aluminium products ourselves. So we occupy that kind of niche space in the inventory. And that is, you know, as we heard before, that's very much a global trade. but certainly one that's really critical in achieving, both, obviously the circular economy, but lower embodied emissions. And so I want to talk now in a little bit more depth about aluminium and kind of what that, really looks like in the circular economy, and then how that flows through into how we think about that and conceptualize it in the built environment. And I think one of the most interesting things and important concepts about aluminium is that it's kind of different from steel. And I think we kind of have this like, oh, we just chuck it all in the furnace and we melt it and it'll be superb and, we'll get new aluminium out at the end. But that's not the way that aluminium works. So when you use aluminium, what makes a really good aluminium can is different from what makes a good facade to what makes a good, luxury yacht, right? And so those properties are achieved through alloying the aluminium metal with something else. So like magnesium or silicon or what have you. But then it's kind of harder to tell what you've got at the end of the day, right? And those alloys act really as a contaminant in the recycling process, and that makes the recycling process less efficient. And particularly when, we've already heard about the really high heat that's required for aluminium, makes it less safe. And so that's why, there's a lot of focus around aluminium. So pre-consumer scrap is kind of this tiny, shiny bit that you can see on the end. And so when Michael talked about the scrap that they're supplying to Margot, that's what that is, right? So it hasn't had a life yet. So that might be, I think you talked about the ends of the extrusions or, the billet ends. It hasn't had a life yet. And the reason why that can be more easily remelted is because you know exactly what it is, right? That was alloyed with, it was probably made even to your specifications. And so it's quite easy then for that re-smelter to go, okay, great, I know exactly what this is. I know exactly the settings to use in my smelter to get the maximum efficiency and the maximum safety to make that into something else. Once it's had a life and it's out there in land, it gets a bit more complicated. So we have some really good streams, like cans is kind of the most obvious one, where if you, put that in your yellow bin or you take it down to return and earn, what we get is a really good stream of just that single product, right? That single aluminium product. And so cans can make it from like a can that you buy to being a new can in as little as 60 days. Because that is a really high quality stream that's generally, depending on where you are in the world and how you do it, but it's generally really free of contamination. And we can actually do that in this country as well. And it's the Boyne smelter that you saw on the map earlier. Is where all the cans go, and the cans are remade in this country. Once you get kind of like over here onto the picture at the end, where it's just a mixed pile of stuff, that equation becomes really different. So when something comes into the Sims yard, if it's a, bit of your building, with it kind of still attached, it's a bit of, the aluminium screen door that, somebody picked up on hard rubbish day and sold to us, we don't know what that was. We don't know what it's been alloyed with. And so it becomes a little bit more of a mixed bag and requires different processing. And the processing looks like the top. That facility is in Perth. That's our Kwinana facility. And when I say shredder, that's what it is. It's kind of a big old shredder. And at the end of the shredding process, you get the three things down the bottom there. And so the guy in his hands, you get steel, right? So, and steel and aluminium go a lot of times hand in hand. So if you think about a car, that's mostly steel, but it might have an aluminium engine block and it's got copper in it, it's got lots of other bits and bobs. And so we will depollute, the car or the appliance. So, if it's a fridge, we'll degas it, we'll take out the batteries, the fuel in the car, etc. But then it gets shredded. And so through use of like eddy currents and, sensors and things, we can separate out the steel. And that steel, when it leaves us, is ready to go back into a smelter. So it doesn't need any more processing. It can go directly from us on the back of a truck and be kind of tipped out, in essence, into a smelter and be made into new steel. You get this product in the middle, which is called ASR, which is very imaginatively named automotive shredder residue, or flock, it's sometimes called, and that's a waste product. And that's all the bits of cement that were left on the facade, and that's all the bits of like plastic from your car dash and foam from the seats, etc. And at the moment in industry, there's no real treatment for that. But that is, I'm pleased to say, something that Sims is innovating. So in Queensland, we're investing in our first pilot facility to actually recover resources from this through an advanced recycling technology. So this would be the first time in the world, I believe, that it's been done with this sort of commodity to use this application. And what we'll do is we'll be able to make hydrogen gas out of this waste product that then can be used to decarbonize somebody else's business or somebody else's transport stream. And so we are really excited about the potential that that has, because just as Sims, we make over 1 million tonnes a year of ASR that goes into landfill. So we're really excited about the potential to not do that and to instead ensure that when something comes into our yard, everything that leaves our yard is a valuable product for society and there is no waste. And the third thing that you get is the Zorba. So if you were wondering at my little kind of Zorba the Greek guy, as well as being a great character in literature, Zorba is the name of the aluminium scrap that comes out of this process. And that is a mixed scrap category. So it means it's lots of other stuff in there that we don't entirely know. And we don't entirely know what that aluminium has been alloyed with either. So that means it kind of gets sorted again. So it's a mixed product there, as I say. And that might be manual separation. So depending on where that aluminium has gone to be processed, it will depend on what happens to it. Like float sink method. So that's kind of, you get what you say on the tin. We like simple names in, in this industry. So, you know, through water separation and various additives to the water, you can separate out, you know, various different components and various different alloys. And other sensors, you know, optical sensors or chromatic sensors, you're looking at reflections and things like that to actually try and get as clean a stream as possible. Obviously, that doesn't all, you know, come for free. That requires a lot of investment, you know, which is why it's really important to think about, if you are doing construction and demolition in your space, where you sell your product and where it's going. So at Sims, aluminium is really one of our focus kind of metals, and you know, there's a lot of driver from, you know, the customer end to be able to get, you know, really good clean aluminium that flows back obviously then through the value chain. And so we're innovating with our Sims Alumisource business to be able to produce a smelter ready product right from the yard. And so that's, you know, really a world first piece of innovation. I can't tell you how we do it because I wouldn't really make it back to Wynyard Station alive. But that is the product that, you know, we are able to produce through our Alumisource business. And that's obviously really important because that means we don't have to do any more processing with the associated emissions and waste and transport that go into all those secondary stages of processing. And the opportunities for that is huge. So this graph is from the Ellen MacArthur Foundation. So, you know, one of our leading kind of circular economy think tanks and not-for-profit. And if we kind of do all the renewable goodness that we can, that solves half the problem. The other half of the problem is embodied in all the stuff that we buy and that we make, and that forms all of our world around us. And so we're not going to achieve what we need to achieve without being fully circular. So there, you know, that circular economy is the way to save the planet. I can't kind of say it any more simple than that. But by doing that, you know, we will also unlock, you know, a lot of jobs and a lot of economic growth in this country. You know, and just, you know, unfortunately, the little screen is over the stat there, but it's more than $2 billion just in this country alone that's estimated we could unlock for the circular economy. So there's lots of opportunities for lead in this country as well, because I know that we're all clever clogs and, you know, we have got the capacity there. We just need to unlock it and perhaps think a little bit differently about it. Obviously, product design is kind of the core when we think about the circular economy. So how does that, you know, how are we designing to avoid waste? When we design a building with a facade, how are we designing that to make it easy to disassemble so that it is a clear stream? That is really important, that we come right back to the beginning there, if you like. Obviously, the design and market and incentives to, encourage people to do that. I talk there about, product design, but it is also, I think about the design of that alloy itself, right? So how do we think about, okay, I want this bit of aluminium to have really high strength and I want it to be anodized, and could that be done in a way that made it more recycling friendly at the end of its life, right? So, how do we think about just actually the metallurgical, determination that we make to make that easier to handle at its end of life? And obviously that innovation, collecting, sorting, and dismantling the product that I mentioned before. Sims is certainly trying to do, what we can, and obviously working within our value chain, because as I said, we are just one part of that value chain. And what comes in the door, really reflects on how well, that can be used in the high value application use of that product in its next life, as well. So look, that's it from me. And I know that I'm the last speaker as well. So thank you again for having me. And, I'll just hand back to Jeff for a few moments here to finish.